Today we are going to talk about the slope failure and the repair options. Mainly, I'll try to answer the three questions: why, and why now, then what. So why a slope will fail, and when a slope will fail, and then how to fix the slope failure. Um, Okay. Although this is not like textbook classification, but we can classify the slope failure into four major categories. This is going to be very helpful in terms of like construction or the maintenance. If you give you the little hint, the global and the structure failure and the erosion and piping and the undermining and the mud flow. For the global structure failure, so, it normally it requires very extensive engineering and a lot of effort. So it's better to contact the either bridge section in your district or the bridge division. For the erosion and the piping and the undermining, there is some chance that you can fix or repair the failure with your the maintenance workforce. And for the mud flow, in most cases, it also needs a lot of engineering. So it's better to contact us. Um, you may put the slope failure back with the same material, but you just buy the time. Okay, let's talk about the global and structure first. The global and the structure failure, it is related to the deep seep failure of the large the slope, either due to the design the oversight or design error, or the improper construction or improper material. And sometimes a soft the embankment can carry a structure like the MSEW or the any retaining wall or the structure like the bridges. So this type of failure can lead a catastrophic failure. So it's better contact the bridge engineer ASAP. So we cannot come up with like a repair option overnight, but at least we can come up with some monitoring program and monitor the progress of the slope failure. Then we can do proper the remediation or the proper action. As a consequence, the repair is going to be pretty high profile, and it's going to be pretty costly. Some of example of the global failure. This is a typical example for the deep sea failure of the global issues, and the picture was taken from in the Oso Bay in southern Texas. And actually, the slope doesn't look like very steep. It doesn't look like 1 ton or 2 ton slope. To me, it looks like 3 ton or 4 ton slope. Um, in most cases, the 3 ton or 4 ton the slope should be stable. But if the embankment was built with the improper material, it can fail. And also, water can contribute to a slope failure as well. For the repair for this type of slope failure, the first either you can remove and replace with a better material and compact better, or you can install the wall system, either cut wall like a soil nail, or the sheet piling wall, or you can put the retaining wall in front and make the front slope or the back slope flatter. So that is the recommended the repair option. This was a slope failure in the North Texas, and a retaining wall built on the embankment consists of the clay. It has a special history, at least for the job site has a special history. So the location where the slope failure occurred, there was the existing previous like drainage ditch or the drainage creek. In most cases, if you see drainage ditch or creek, there is a soft deposit due to alluvial deposit carried by the water. So if you see the existing pond, creek, drainage ditch, and you should make sure you remove all the soft material and replace with a better material. Then this picture is a progress of the slope failure. At this time, you lost the MSA wall and the pavement and also embankment. So the repair is going to be build the new the retaining wall in front of the failed slope, and remove entire MSE wall and redo the pavement, which is pretty expensive. And also, the new MSE wall is founded on the very hard limestone, so it performed very well so far. And another type of the slope failure is the erosion. So erosion is normally due to the surface water, such as like a runoff, and it is not considered a design issue, but it is very important to make sure all the water in your job site properly drained out. So during the design stage, make sure that all the drain is properly installed. Um, Normally, it is very common in the sandy soil or the silty soil because there is no stickiness between the soils, so it is very easy to wash it out. Um, then the control remediation or control is going to be, first the control your water properly. So using either divert the runoff, and the concrete curb is very good and is very cheap to divert water. So using the concrete curb, or you can use the flume, concrete flume, or you can put the shoulder drain, especially at the at the end of the bridge or the approach of the bridge. So you can put the shoulder drain at the approach. Then also you can control. If you put like a shoulder drain, the shoulder drain will carry the water, and it may erode the soil at the exit of a shoulder drain or the flume. So in this case, you can put like concrete dissipator to lower the the energy from the running water, or you can put the storm protection at the exit. Also, you can use like vegetation to control the water, or the using the control blanket or mulch or the compost. This is the typical the erosion failure or the erosion issue in the sand or the silty material. Um, so the surface water can make the pretty the large the erosion issues. Um, so the best way is the properly the drain your water or divert or the protect your surface. Piping and the undermining. Normally, piping and the undermining is due to the concentrated water the under the structure. Typical the location that you will see undermining or the piping issue is the bridge approach, either under the concrete rim wrap or the around or below the abutment cap. Um, if the undermined section is large enough, and if the structure such as like concrete rim wrap is already failed, you can use the cement stabilized sand and compact it and rebuild your structure, failed structure. Um, so sometimes it is not very obvious that there is the piping or the undermining until the concrete rim wrap or the other structure collapse. But there is some chance during the inspection the sound the concrete using the hammering or the dragging the chain, and if you see that there is the void under the structure, you can feel with some flow feel. Um, so this is the typical undermining the below the concrete rim net. It seems like it is the river environmental or the lake environmental, and this is like concrete rim wrap over the embankment. So it appears the either the wave action from the river, the wave due to the wave action, the silt or the sand material eroded out, and then the concrete the rim wrap collapsed. To repair this kind of the failure, first you can remove the failed concrete, and you can place the cement stabilized sand, or if you want, you can put the aggregate. Then make sure that you put the segregation filter between the aggregate and the sandy material, and rebuild the concrete rim wrap and seal all the joint. And also you can install the little bit deeper tower at the end of the concrete rim wrap. This is also typical the undermining and the piping failure. So structure collapsed. So then remove the structure, and you can place the you can place the cement to stabilize the sand and rebuild the structure. And I would recommend to put the concrete curb around here to divert the water. And you may consider the put the shoulder drain to down, and may put the dissipator or the storm protection at the exit of the shoulder drain. Um, the piping undermining the initial finding is very important. If you find these issues, you can fix very easily. But if you just let it go, the problem can be very significant. Um, as I told, if the structure is still standing, you can use like a floor fill, which doesn't require the compaction. Um, the treatment of the diverting water is very important, and also you can use the aggregate or the cement to stabilize the sand. One of the problem for the undermining or erosion, especially at the breach abutment the side, is if you lost the a soil, the header bank. So there will be the abutment the structure. There will be either the through shaft or the piling. So it depends on the geometry or the embedment of your foundation. The foundation may lose its lateral stability. So somebody needs to check the lateral stability of your abutment foundation. So if you see the lateral stability is the issue, and if you have the enough excel on the capacity, then you can consider the repair option that Christine presented in couple the presentation ahead, like drive the sheet piling at the back side of your bagware, and separate the lateral load pressure subjected to the bagware. That is one of the possible option. And also as Christine presented, put the retaining wall in front and make the back slope flatter. That's a very good the repair option as well. As you know, any issue related to impact rail loader is not very easy issue to solve. So better to find the problem early and contact us. Okay, mode flow failure. Mode flow failure is not the typical textbook the terminology, but it can describe the progressive the shallow failure very well. Okay, I prepared some the flipbook animation. Not this one. I'll show you later. The mode flow is like a progressive the shallow failure, and this is the most common the slow failure in the highway structure. This type of the mode flow failure can occur at the slope consists of the high PI clay, and also it takes the considerable time to make entire failure. Is going to be progressive. It may be fail, stop, things like that. Water is always the culpable, and it's a little bit harder to prevent or the fix with your maintenance the forces. You can put the slope back, but you just buy time, and it requires some design, the extensive design, the actual engineering solution. One of the typical the failure. This is it seems like this is like the combination of the deep sheet failure and the shallow failure, which is the mode flow type. And this is the typical example for the mode flow failure. So you can see the series of scarp of the failure surface. So it starts from very small failure in the middle of the embankment slope, and it failed, and then it formed a scarp at the end of at the top of the failure surface. Then it's exposed to the water. Then water worsen the failure. So there will be another failure, following the initial failure. Um, so the yeah, this is not good, at all, right? Um, so this is the indication that how bad is the embankment material. It is a very high PI clay. So actually we tested the the plastic index actually is tested by the Texas A&M. The egg is we installed one of the monitoring thing as a part of the research project. So the PI, as I remember, is like a 70 or 65, 70-ish, which is a very high PI, and it performed okay for about the 15 years, and then it failed. So the question is, why the slope fail after 20 years? And sometimes especially for the embankment made of clay, it takes time to hit the fully drained condition, or it should meet a condition that I'm going to describe later. So it's more like perfect storm case. If you hit the perfect storm case, it's going to fail. Um, Eventually, we had to rescue our bulldozer. Um, so this is the final final the solution for the slope failure, and it's just before the put the vegetation and put the railing, but pretty much like we installed the soil now, and we put the fascia of the soil now. This is the sculpted granite fascia, and it's just the side the information, and the precast panel is the most common, but also you can put like a sculpted granite. So basically, you just shoot down the shotcrete, the granite, and you can sculpt this thing. So it's pretty much like an archy, the archy construction. So actually, the sculpture, they made this thing one by one. So you have lots of the options to make your work pretty. Um, okay, the problem of the high PI clay, and it absorbs a large amount of the water, and it swell and soften when it is wet, then shrink and crack when it is dry. The shrinkage crack in the clay open up when it is dry, but it's not going to close down when it is wet. So that crack, the shrinkage crack, can serve as the revenue for the normal porter can get into deeper. So basically, your embankment or slope slope has access of the water at the deeper the depths. The PI test is very simple. I think the most the district lab has the capability to run the PI the test. It can be done like a day. So I recommend to run the PI test first if you see any the slope failure. So first thing, the easy, quick, inexpensive the action that you can do, you can run the PI test. That is very good information. And any embankment material with a PI higher than 30, it can be trouble. It depends on the the resource of the water or the slope. But there is the high potential that the embankment may fail. This map shows the distribution or the location of the the swelling high swelling potential the clay. The red color shows the high potential clay. So this line goes San Antonio, Austin, and Dallas over IH35. So so I didn't check like every individual embankment, but there is some potential that the embankment on the slope may fail along IH35. Um, so why do high PI slope fail? One of the process or the progress of the failure, and as I told you, when we build the embankment, it's going to be dry and well compacted. Then it's going to experience the dry and the wet season, and dry and the wet season, and it create the crack. Then this is like a flip book animation like that. I thought it's pretty cool. Yeah. So it make the initial the slope failure, and it forms the complete the failure, and it slides down, and also this provide the access to the water for the upper slide. Then it keep failing until we fix or we replace the bad material. Um, okay, so how to fix it? So water, water, water. That's the answer for the most of the slope failure. So divert the water properly, and you can use like a vegetation, same as for the erosion, and avoid the rutting in the embankment. In some case, you cannot stop the slope failure. So it's better to fix permanently. The repair option normally can be flatten the slope using the retaining wall and flatten the side slope or the back slope, and also add drainage, and or you should do combination of the above. And the remove and replace is the quick easy option that you may think. And the remove and replace you should remove your soil. You should remove all the failed soil. If you record the Geotech 101 and the stress strain and any the strength test, you see the strain and the stress goes up, and it's going to hit its peak the stress, which is the peak strength. Then it goes down and stay flat, which is residual stress. So if you just leave the failed soil, so basically the failed soil is worse than the original soil. So if you put your slope back with the same slope, it's going to fail because the factor of safety of the failed the slope is going to be lower than the initial the factor of safety. Then replace with what? So then you can bring the better material, which is low PI clay, or you can replace with like the dirty base or the reclaimed base, or you can modify your the soil with the geogrid or the steel mesh. The properly limit or the properly specify your embankment material, which is item 132, is very important. Item 132 type C is the requirement specified in the plan. So normally make sure you limit your the PI properly, and do not allow any the material not meeting the PI requirement. So this simple chart provide the recommended slope, and normally the PI limit is what? So as I have seen, the maximum limit is about the 25, and the lowest is about the 8. So this is the recommended the slope. So this is very conservative. So if you properly the design, you can put a little bit steeper slope than this one.